Hello everyone. I want to begin by extending my thanks to the Chemistry Club IISER Bhopal for giving me this opportunity for the interview. I also want to express my gratitude to Professor Vishal Rai for giving us the opportunity and sharing his valuable insights. Thank you.
Thank you very much.
So let's get started. And so, talking about the basics, can you walk us through your journey?
Well, my life journey started from Lucknow, and that is where my parents were when I was born. And then we kept shifting from one city to the other city. I guess 3 to 4 years in each city. I guess the longest I spent was in Varanasi during my school days, um, studying in BHU in Kendriya Vidyalaya, and then moving to uh, BHU in Department of Science for bachelor's and master's as well. So most of my student life, I would assume, went in the BHU campus. And if you have been to this place, you will realize a beautiful green campus with a lot of opportunity for sports and various other activities. So sports was one of my things in addition to the studies. Um, and that's more or less it. After completing my master's, the obvious next step for me was to go for PhD, and that is when I chose to join a research lab in IIT Bombay, Department of Chemistry, and then I spent 5 years over there before moving on to the next obvious step for me, which was postdoctoral research, and that was at University of Toronto in Canada. I was there for approximately 3 years, uh, and that's more or less my overall journey from childhood till starting my career. Yes.
Sir, what motivated you to join IISER Bhopal?
So when I was in second year of my postdoc, that was the time when I was looking at all the possible opportunities, and I was assessing my possibilities in both academia and industry. For various reasons, the academic job opportunities outweighed my choices on the possibilities in industries. And then I was looking at various places, not just India. So my first three applications were in three different countries. In India, IISER Bhopal was my first choice. One of the reason was uh, the fact that I was aware that the fundings in this institution is going to be good, and it was also quite clear after the interview that the institute is going to support my financial requirements for setting up the lab for the type of research I wanted to do. So it was only after the selection and commitment from IISER Bhopal that they will be able to fund my requirements. It was clear that I'm going to go for this choice. But yeah, at the time of applying, my options were open, and one thing that I was very clear about was what research I want to do. But then I was looking for an institution that can support my requirements to do that research.
So talking about research, your research is in protein bioconjugation, and can you explain us what protein bioconjugation is and what drives your passion for it?
So again, to explain my passion for protein bioconjugation, I'll have to go a step back. I started my research journey as an organic chemist. So I started looking at how we can engineer bonds in molecules, either through bond formation or through bond dissociation. And that is what my first 5 years of research journey were, where I was looking into these processes and also how I can control stereochemistry and other aspects while doing that. Even in my postdoctoral research, the molecules that I was working with were a bit different than what I worked in PhD. The methodologies were different, so the processes were quite different, and they gave me unique experiences. But it was still organic chemistry in general. But the last part of my postdoc, where I was leading my team in a collaborative ecosystem, working with Department of Medicine and a few others, uh, we were trying to solve one translational problem. And it was almost 1.5 years of effort where we tried really hard to see if we can develop a cyclic peptide base inhibitor for a specific protein-protein interaction. And we found that while we had good candidates for targeting this protein-protein interaction in cells, things were not getting translated very conveniently to the animal models. And while I was not doing any of the biochemistry or animal biology part, the overall engagement and the discussions kind of you know inspired me to see why was it that we cannot translate this chemistry from cells to animal models. How is the level of complexity different? And one of the ideas that we tossed was, how about we put up a probe so that we can see exactly where things are going wrong, right? Is our molecule even reaching where it is supposed to reach, and so on and so forth. But in this discussion, we also realized that you can't simply take a protein and engineer a single bond very selectively. And the general thought process in the field was that the chemical methods are not capable of doing precise engineering of proteins. And the reason was quite obvious, as discussed in our team, that hey, it's just too complex, lot of functional groups, and their competition is you know at a level where you cannot really pinpoint one single functional group at one single site that would offer unique reactivity. So this is something that stayed with me, and I kept thinking about it for a year, that can something be done in this perspective from organic chemistry direction? So can we understand the physical organic chemistry principles of why this cannot be controlled? Um, and if we try to do that, maybe we will be able to find a way to say that, yeah, it is possible if we control the parameters in certain ways. So that was the initial drive of why it drew me towards this side. But then I also realized that my background was not in proteomics, which is going to be one of the key analytical tool if I want to work in this area. So I guess we took a calculated risk in the beginning. We believed that when we will start learning proteomics, we will be able to learn it, and when we move forward with that leap of faith. Um, and then eventually, over a period, um, the first generation of my team members, my PhD students of the group, they were able to discover methods and principles that would clearly tell that it will be possible to control the selectivity, and in more than one ways. So this was first 5 years, and that kind of gave us enough confidence that okay, uh, now if we systematically move forward, then we should be able to meet the technological demands that already exist in the field of biologics, which involves protein and antibody based therapeutics. And hopefully in the longer run, we will be able to even come up with a small molecule precision therapeutics. So translational technological demands was one of the driving force. So what excites me in this perspective as an academician is that we keep learning organic chemistry at different levels of complexity. Um, we know that there is a functional group present alone, and we can do a certain type of bond formation with it. We know that this functional group can be present in um, a larger molecule, and this ecosystem of all these additional functional groups, how do they affect the property of this one functional group? And if we keep in understanding this at different layers of complexity, you can imagine that we are actually moving from a small molecule to a protein, or a protein in a cell or a living organism, which can be even human being. So there, it just provides an opportunity to learn so many dimensions of science, which is what we find very fascinating to pursue. And while we are doing this, we also realize that there are a lot of philosophical connections of how human behavior or behavioral science proceeds, how neuroscience proceeds, and how the philosophies of these dimensions of science are also connected with uh, something as simple as bond formation with a protein. Yeah, so these are the things that keeps us excited about what we are doing. A lot of learning almost every day.
It is quite fascinating to hear about all of this from you. Like as you said, during the process, you've seen things that have made you more excited, and then you wanted to pursue it. So there are people even in like BSMS over here, and students who are generally have just entered in science. So what do you think is, how do we find the passion that we want?
Okay, so it's a good point, and this is something that I quite frequently discuss with BSMS students, first year to third year students in particular. Um, so in the beginning, it will be very difficult to figure out what you like and what you don't. The only thing that I would mention here is that you will have to explore a few things. You will have to learn a few things to know whether you like it or you don't like it. Quite often, I have noticed that in some of these students, if they don't understand a subject, they would say that, hey, I don't like that subject. So the choice of words is important. It's just that you tell yourself that I don't know this subject yet. uh, because for liking or disliking you have to know something first, right? So, and obviously you also have limited time, so you can't know everything, so you will have to make a judicious choice of few things that you would like to explore, and then make a choice of what you like a little more, right? There are multiple right pathways for doing things correctly. So if it doesn't matter whether you choose a stream A, B, or C, you will still end up solving probably important questions in the coming years if you are keeping rest of the attributes proper. So for most of the BSMS students, if I will be in that position, what I would probably do is that I would explore a few dimensions, see what excites me a little more than the other things. It doesn't mean that I'll stop learning the other things, because after a point, the research connects all the dimensions of science. And you will notice that human brain is not very broad in terms of thinking. The philosophical way of thinking by people in one discipline quite often overlaps with the other disciplines as well. So if you're spending time in one dimension and later choose to go in another, those learnings would still be helping you. So first year, second year is the stage when you can still explore, and if you notice your system, you will be taking a pre-major at a certain time, and then you will be further narrowing it down. It kind of gives you a systematic opportunity to see what you like more, and then keep narrowing down further. Um, After narrowing it down at the end of BSMS, you will then realize that if you enter the research programs, it again broadens up, because the real problems in the community and science, they are not bound by one discipline or the other. So the process of your learning right now also kind of trains you to have an open mind towards other discipline, so that later, if you, let's say you choose chemistry as a major and you do research in that dimension, you can still be open towards the technological requirements that can be met by, let's say, physics or engineering, or medicine for that matter.
So looking ahead and envisioning the future, what do you think the future of your field of research will be in the next decade?
Okay, so it is very interesting how this field of protein bioconjugation is shaping up. In last 6 to 7 years, our group and a few other groups in the world, they have been able to demonstrate that it is really possible to develop chemical or biochemical technologies for doing precise engineering of proteins. Now, these different technologies, they operate in different realms. Means some of the biochemical technologies are great for studying proteins in cellular environment. They cannot be translated really for therapeutics. Same way, even our technologies, we have a few that would work very well with isolated proteins. So if somebody wants to take a therapeutic insulin and wants to engineer it, it will work very well. Or antibody conjugates, it will work very well. But the same technologies are not going to be appropriate for targeting the complexities, for targeting a protein within the live cell or a living mm, animal, right? Including humans. So this is where I can see that the field is already maturing. Um, so now what is happening is that the biochemical methods, the chemical technologies, they are addressing different type of questions. While biochemical methods is helping in understanding the biology better, the chemical methods are already helping biologics, and it has not yet reached the market in most of the domains, but it is about to. And in the next 10 years, you will notice that biologics, where protein and DNA and RNA and cell-based therapeutics is involved, this is the most rapidly growing sector, and it will continue to be one for at least next few decades. So these technologies are definitely going to go forward and enable these segments to grow faster. But I can also see that the world of chemoproteomics and development of covalent inhibitors, which is coming in the segment of or the attempt towards precision therapeutics, that is going to merge with this dimension, because the principles that regulate the selectivity, they would be translated in that dimension in the coming time. Again, very few groups are attempting this, because this becomes highly interdisciplinary after a point. But there are groups that believe in it, and there are many who believe in these groups. So the idea is going to move towards the dimension where you can imagine having um, drug molecules that will be far more specific than what you have today in the market. So at the same time, what I also expect from the academic perspective is that it is going to add a new dimension in organic chemistry textbooks. So do not be surprised if just 5 years to 10 years down the line, if you see additional chapters in organic chemistry textbooks where the organic chemistry is translated to biomolecules, and it presents new dimensions of selectivity parameters for people to learn. So sorry about increasing your syllabus, but that is likely to happen in the coming time.
So what inspires you and excites you about research, and what are the key elements of effective teaching according to you?
Okay, so one of the most exciting part of the research is that we get to learn new things almost every day. And the other critical aspect which keeps you driven is the potential to contribute towards the society. Now, uh, if you notice, teaching and research are very well connected with each other. In research, we, the whole team, we keep engaging in discussions very frequently, and the idea is to, talk about what we think, what we believe in, how our ideas are backed by facts that are coming from literature, and to convince my team members that it is something worth pursuing. And they will also try the same thing, and we will be assessing their ideas, right? If you notice, this philosophy of communication of scientific facts is not very different from what happens in teaching. We are talking about the concepts that we understand in the best possible way that the students can understand. And not every student is same, so they have different thought processes. Some of them would process it in a one way and some in other way. So different types of question will come up. We will again engage in discussions, and this will help not just understanding the concept, but also to strengthen ways of understanding this, right? So you can have fresh perspectives of understanding the same thing. So the way of communicating this, the way of understanding concepts, it doesn't change whether it is research or whether it is teaching. I hope you understand by this that I am saying that in teaching, it's not just the faculty members who are teaching. The students, by asking question or raising their fresh perspective, they are also teaching at the same time, right? Um, and so this overall process, uh, make sure that you are learning, you are enhancing your skills over time. But if you want to continue doing it for a very long time, I guess for me at least, the biggest driving force still remains, um, what impact am I actually making? Am I contributing to the society? So by teaching, you still get a little bit of satisfaction if your students do well, if they have understood the concepts. You get the satisfaction that, okay, I am at least contributing towards the next generation of citizens of this country. And when it comes to the research dimension, it is more about having the belief that can you, in the long run, contribute back to the society through your science? Will your science make some difference, which is actually going to make few lives better, if not a lot? Yeah, so that remains the main driving force in most of this journey.
So, do these numerous achievements continue to hold the same significance that they used to?
So if I have to explain it in terms of organic chemistry, the achievements are always kind of co-products, and the recognitions. So they belong more to the group, because it's my team members who invest equally hard work. And my contribution, if I have a team of 10 people, then my contribution is 10%. So the recognitions are all, I guess, that is for my team members. It does help at times for getting the research funding. So for me, its value is only because of the fact that it sometimes helps me in getting better research fundings. Beyond that, I don't really think too much about it. So even when we got it, or now, it doesn't matter beyond the fact that it kind of enables research funding. But we are really thankful to all these different agencies, government and non-government, for recognizing our research area and also helping us in a way to reach out to more people in the younger generation to tell that, hey, this research area is also important.
So, what advice in general would you like to give to the people who are going to pursue research or are pursuing research?
Not much. It is same as the advice what I would give to any student when they are pursuing, let's say, their BSMS degree. Um, if you are studying, the important question to ask is, why are you studying? If it is for knowledge, then you will have to focus on building the knowledge, and the focus cannot be the CPIs, right, or the marks you get in any exam. Uh, Now, marks in this case can, if you're studying well and you have a good knowledge of the subject, the marks will come automatically, right? But I hope you understand there is a difference whether you're focusing on the building of knowledge or focusing on CPI. In one case, if something is out of course, you will not read it because that's not going to come in exam. Whereas in the other case, you will probably still read it because you want to understand it completely, right? So my suggestion to students normally is that you focus on building up the knowledge and don't worry about CPIs. They will come eventually, because afterwards is the knowledge and your confidence in the breadth of your knowledge that is going to stay with you. The same applies in the case of research. If the focus is on the scientific questions, why you are working on it, now what are you going to do and how are you going to do it, right? If that remains the main focus and the objective is clear in your mind that how eventually it will serve the larger picture, then it becomes it keeps you engaged for a longer duration. You will keep finding it exciting. But similar to CPI, if the focus becomes paper, the number of papers, then after a point you will lose interest in it. So ask the right question to yourself: why are you doing research? Is it for papers or is it for scientific discoveries? And if you're asking right questions and answering them honestly, then it will keep you engaged for a very long time and keep you excited.
So, sir, we students do face this competitive mindset and the dilemma of scoring good marks and getting the knowledge that we want. So, during this process, we often one or the other things gets affected. How do we try to balance both of them?
So you would realize that every individual is unique, and they're not going to be, um, you know, they're not going to be same as anybody else, which is a great thing. And when you're competing with someone with a certain question paper, um, this question paper is obviously going to check your knowledge in that particular questions, which really doesn't define you who you are. So from the student standpoint, if they are competing with other students, I do not know how valuable that would be as an approach. If they are trying to get the best out of themselves and they are just trying to be best of what they can be, and in an honest way, they are investing the effort, that should be good enough. So that kind of ensures that you will be in a good mental space. I know that some people use the competitive nature as a driving force. So if it helps them, it's good, fine. If they're mentally strong by not getting affected by it, that's also fine. But at the same time, if I have to follow it, I still follow it in research, where I'm only trying to focus on what I can do the best. If others are doing well, that inspires me, and I enjoy their successes. I get to learn about what they have discovered, but I'm not going to be competing with them, saying that, hey, I need to do better than them. I, I just have to do the best I can do. So that's the approach that I prefer to follow. But I would say that it is very individual centric. If some individuals get positively inspired by being highly competitive, good for them, they can adopt that approach.
So, and sir, talking about chemistry in general, if we see historically, chemistry has evolved in every century and the numerous evolutions have led to our thinking patterns changing like every day. So now, when we talk about this stuff like the discovery of electrons and subatomic particles, during that time, people were not they didn't accept the idea, and the people who were trying to discover, like people who discovered it, did face a lot of backlash. So doing something that is not conventional, you always have a pressure on yourself that the society is not going to accept me. And with the world of social media now, that is more amplified because you do one thing and the whole world knows about it. So there are plenty of people trying to suppress you now. How do you give yourself the drive that I am doing the right thing?
So it is it's like mathematics. You keep the number of variables limited, a number of parameters limited, and the thinking would become simpler. So same thing applies in our case. If we are going to think about what others would think about our research, then it is just too much of undue pressure. So I do not think any scientist would care about this aspect. They will rather focus on the scientific question. Does it make sense to them? Do they think it could lead to a discovery that can benefit people? And then it is worth pursuing. And it really doesn't matter how people react on social media, or in fact how people react in the scientific community itself. General public is not completely engaged with the scientific community, so they don't get to know about the scientific discoveries right away. But even within the scientific community, a lot of backlash comes, as you mentioned, if you are challenging the pre-existing notion, right? Which is fine. So people would probably in the beginning try to refute your idea, and over time, when they find that hey, others are also getting the same thing, and they will eventually accept it. So that's a normal process. But as a scientist, I don't think anyone has to bother about those aspects while pursuing a research question. If it makes enough sense, if spending time or investing your precious time on that could lead to an answer that can help people, then it is definitely worth pursuing. So yeah, but at the same time, even for scientists and in general, it is good to kind of filter um, social media access, and try to engage with it till it is constructive, and disengage yourself when it becomes a non-constructive thing.
So, sir, with the rise of social media, do you think the reach that social media is providing that impacts your research or funding in any way?
So, social media, like any other media channel, is definitely a gateway for reaching out to people and creating impressions. And if these impressions can create favorable biases or sometimes unfavorable ones, then they definitely affect the funding for sure at times if these people are decision makers. Uh, but at the same time, these are always going to be these subconscious biases. It won't be more than that, because most of the people who are associated with the funding committees, they are scientists themselves. So they keep all the perspectives in mind before taking the decisions. But I would say that if you're doing everything right, this can add maybe 0.5% to 1% positivity to your chances.
So during when you we say positivity, has it increased? Like, do you see an increase where because of social media?
That is very difficult to quantify. There is no control experiment, right? So unless you have control that without social media reach, what happens, and with social media reach, what happens, you would not know if it positively impacted.
Thank you so much, sir, for your time. It was my privilege to be here, and I also thank the Chemistry Club IISER Bhopal for bringing me here for the interview.
Uh, Thanks a lot for giving me this opportunity. And I must also thank Chem Club for taking this initiative and doing this exceptional job. Thank you very much.